estimating a population proportion. By the end of this video, you should be able to construct and interpret a confidence interval for a population proportion, and you should also be able to determine the sample size required to obtain a particular confidence level for a confidence interval with a specified margin of error. All right, so for today's scenario, we're going to estimate what proportion of the Earth is covered by water. So we're going to investigate this because by taking random samples of location on the globe. And I have done this, but I wanted to show you how I did this. So on random.org, they have a random geographic coordinates randomizer. So you just say pick coordinates, and it will show you, so this one's in the water. Pick again, that one's in the water. Pick again, water again. This one's on land. And so I did this 50 times to collect data. So randomly picked 50 different coordinates to see how many of them were in water versus not in water. And I took 50 samples, and 34 of these samples had the pin land in the water. So that gives us a p-hat of 0.68. So we're going to construct a 95% confidence interval to estimate the proportion of the Earth that is covered by water. So we want to state the parameter that we want to estimate and the confidence level. Okay, so the parameter, we're saying P is the true proportion of Earth covered by water. And we want to have a confidence level of 95% because this is constructed 95% confidence level. All right, so as we're going through this, this is a very formal 4-step process is what it's called. And so this is how you're going to want to structure your answers to these kinds of questions where we have a state phase. And in the state phase, you want to state the parameter and the confidence level, just like we did here. You may not have the prompts. You just need to remember what goes in the state level. Next, we're going to deal with the plan. The plan is where we're going to identify what we're doing, what's the whole purpose of what we're doing, and check our conditions that we discussed last time. So the name of this procedure, it is a one sample, because we're not talking about a difference of proportions here. It's a one sample. And we're going to use Z star because of the 95%, so we're going to say Z star, Z interval, because we're making a confidence interval. And we're doing this for finding out the true population proportion. So one sample, because we're not talking about a difference of samples, one sample Z interval for proportions. All right, now our conditions. We discussed this previously. You have to check these each time. We have random. Okay, we had a random sample of 50 locations. I use that random generator for coordinates. So we definitely had our random sample of 50 locations. The next thing you need to check every time is the 10% condition. So we checked 50 locations on the Earth. Those 50 locations are definitely less than or equal to 1/10 of all the locations on Earth. And then your last one is, because we're talking proportions, you want to check the large counts. Okay, so we had a sample size of 50, and we were successful 68% of the time, which is 34, definitely greater than or equal to 10. And then 50 times the times we missed was 16, which is greater than or equal to 10. So we are approximately normal here. Okay, so now before we move on, I want to just stop and talk about these. The conditions, to remind you why we do them. Random is so we can generalize to the population. Okay, because that's our whole point, is we're trying to infer back to the population, so we need to use a random sample so we can do that. The 10%, so we're showing that sampling without replacement is okay. Sampling without replacement, okay. And that's so we can use the standard deviation formula that we're going to use. Otherwise, we would have to use a different one that we're not addressing in this class. And then finally, large counts. It's so the sampling distribution of p hat is approximately normal. So the sampling distribution of p hat is approximately normal. Okay, and so they have reasons they have to be checked each time. It's part of our formal process here. So we had state, we had plan. Now the do part. Do is what you're going to do the math. Okay? So if the conditions are met, you're going to perform the calculations. So we have a general formula. So this is where we write the formula in words. Specific formula is you're going to write the formula. Then you're going to plug in the numbers. And then you're going to actually calculate the answer. So to find a confidence interval, in words, what you're doing is you're taking a point estimate and you're adding and subtracting a margin of error. Okay? Now, what that looks like specifically is your point estimate for proportions is p hat, plus or minus, and then to get a margin of error, you need to have your z star times your standard error. Okay. Now we're going to plug in our numbers. Our p hat was the 0.68 that we got above. That's what we got in our sample. Plus or minus z star for a 95% confidence level is 1.96. And then for our standard error, we use the 0.68 times 0.32 divided by 50 because we took 50 samples. Now our answer, I'm going to just kind of show it out so you can make sure that you can get this plugged into the calculator correctly. So we have our point estimate plus or minus our margin of error of 0.129, which gives us an interval of 0.551 to 0.809. So make sure you're able to calculate that and get the same number into your calculator. All right. So we stated what we're doing here, what we're looking for at our confidence level. We went into our plan, which is what procedure are we using, and we're going to keep building in procedures. Checked our conditions. We did the math and created our confidence interval. And the last step in all of this is to conclude. So that's just where we interpret. And I gave you the interpretation on the first day. So we are 95% confident. The interval, and then just name the interval, 0.551 to 0.809 captures the true proportion of earth covered by water. So we're 95% confident that the interval of essentially 55% to 80%, 81% captures the true proportion of earth covered by water. Well, the truth is, because this is another one of these known things, a lot of times when you're doing this, you don't know what the truth is, but I'm finding scenarios so I can show you that you were pretty accurate with what you've gotten. In truth, about 71% of the earth is covered by water. Okay, so that gives you a P, a population proportion of about 0.71. All right. Let's flip this over. I got a couple things. One's a summary, but one's a new piece of information. All right, there's two things that need to happen back here. One's going to be a summary, and choosing the sample size is a new piece of information, so I'm going to be sure I draw it out for you. Okay, so our four-step process. In the four-step process, you must have a state section. Now, you do not have to label it state. I tend to like to do that because it helps me kind of keep track of where I am in my process. For the state, you must define your parameter, which we have been doing. We say the P represents the true proportion of earth covered by water. So define your parameter and put the confidence level. That's what I want to be sure you include in that section. In the plan section, I want you to name the procedure, and we're going to keep adding new named procedures as we go along, as we learn more. And then this is where I want you to check the conditions, and you have to write them out. Okay? So that's your random, your 10%, and for proportions, large counts. Okay? Then we're going to have a do section. Now for this, I want you, for right now, to write the specific formula. And that is the actual formula. You don't need to tell me the words one, but I definitely want the specific formula. Okay? And then after you write it, then rewrite it by plugging in numbers. This is part of the process of learning all this information. Okay? And you'll get your answer here. You'll create your interval. Right. And then we have conclude. And I want you to interpret the interval in context. And remember, that's like we are 95% confident. That one. All right. This is our very formal process, and this is as streamlined as I can get it. Okay, so this is what we need to be doing for each time. Now, a new piece of information that I want you to have is how do you choose a sample size? So before you've collected data, how do they know how big of a sample size to get? So when choosing a sample size, where sample size comes in is in your margin of error formula, because you have Z star times the standard error. Okay, so this is where we have sample size, and you're going to end up solving for N. So I got to do some algebra in there. So for proportions, when your p-hat is known, because you haven't collected the data yet, that's the whole idea behind this, is you want to know how many people you have to talk to get a particular margin of error, okay? And so you haven't talked to anybody yet, so you don't know the p-hat. We are going to use p-hat equals 0.5 because it's a conservative calculation. And what that means is that is the most error that you can get before the numbers just swap places on which is bigger, the success or the failure. So this is like maximizing the error. And so we call that conservative because it can't be any worse than this, is what we're saying right here. Okay, so you haven't performed the study yet. You're trying to decide how many people we need to talk to. So we're going to use p-hat equals 0.5 because it's the most error possible. Okay, and once you're done calculating this, if you solve it all out and n is a decimal, always round up. Always round up, even if it's only 0.1. That's another conservative. It's better to talk to more people than less people. Okay. Plus, if you have 427.2, you started talking to a whole nother person, the 0.2, so you might as well count them. Okay. All right, so for your check your understanding, here's the scenario. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some ideas about the sample size she'll be required to pay for. One value of interest is the proportion of customers who are satisfied with the company's customer service. The president decides she wants to have an estimate be within 3 percentage points at a 95% confidence level. Okay, so 3 percentage points, 0.03 is your margin of error. Okay, and your confidence level is 95%, so that's going to give you a z-star of 1.96. Okay, so hopefully we're remembering that. Now, I'm going to get you started into setting this up. So remember, to find a margin of error, you have to take the z-star times the standard error. So in this case, the margin of error is 0.03. So I'm going to say 0.03 equals 95% is 1.96 times. Now, they haven't done the study. This is where we don't know p-hats. Remember, right up here I said if you don't know what p-hat is, this is maximizing the error that can possibly be there. So we're going to say 0.5 times 0.5 divided by n. Now, it's up to you to rearrange this to solve for n. All right, and then you're going to go on and answer questions 2 and 3 also. Check your work when you're done. Let me know if you have any questions, and I'll see you in class.